Hello friends, in this video I'm going to tell you about the next question, which is from the Gauss forward formula. So let's see. Firstly, we consider from the following table. We have x and e to power x. So firstly, x has the given values 1.00, 1.05, 1.10, 1.15, 1.20, 1.25, 1.30. These are all the values given in the x. And for the e to the power x, we have other forms, that is 2.7183 and so on so on. So these are all this value, and we need to find out the value that is find e 1.17 using Gauss forward formula. So as we could see that the given table has all this value, and the 1.17 will lie in between 1.15 and 1.20. So in while finding through the Gauss forward formula, we basically see that the top value which is near to the given value, we choose that one. So for the 1.17, we chooses 1.15 as the initial value, that is x naught. So let's see that. Firstly, we will form the table for this. So let's form the table for the x and e to power x, that is 1.00, 1.05, 1.10, 1.15, 1.20, and 1.25 and 1.30. These are all these values. We have seven values. So let's write the value of the e power x, that is 2.7183, 2.8577, 3.0042, 3.1582, 3.3201, and 3.4903, and 3.6693. So while using the Gauss forward formula, we just firstly we find out the its set. So the first difference table, that will be del, then del square, del cube, del power 4, del 5, and del power 6. Since we have seven values, so we'll have to calculate till the 6. So as we can see that we have there's always value. So for the first difference, I will go through the lower value minus upper value, that is 2.877 minus 2.7183, that will be equals to 0.587, same as it is. We're going to do minus 2.8577, that will equals to 0.1465, and 3.1582 minus 3.0042, 0.154, and 3.3201 minus 3.1582, that will equals to 0.169, and same for the 3.4903 minus 3.3201, that will equals to 0.170, and 3.66993 minus 3.4903, that will be equals to 0.179. Actually this is 1.394 here. And next one we have to do the same for this, that is 0.1465 minus 0.1394, that will equals to 0.0071, and same for the other. 0.154 minus 0.1465, that will be equals to 0.0075, and then 0.1619 minus 0.154, that will be equals to 0.0079, then 0.1702 minus 0.1619, that will be equals to 0.0083, and 0.179 minus 0.17, that will be equals to 0.0083. Same, in the same way we have to find for the del 3, that will be equals to 0.0075 minus 0.0071, that will be equals to 0.0004, and next one is 0.0079 minus 0.0075, that will be equals to 0.00014. Next we have to find 0.0083 minus 0.0079, that will be also 4. 0.0004, and the next one is on that will get 0.0000. Sorry, this one is, yeah, here it is 8. So I'm getting, we will get here 5. Next we have 1. So therefore we get 0.000, and then 0.000, and for this we will get 0.00011. So next we have to find on this value we will get 0 and 0 0, and for this value we will get the same, that is 0.0001 as it is, and for this value we will also get 0.0001. So since we have all the data here, now since we know that our value for this is x naught is 1.15, and y naught will be 315482, and this way we will go through and we will find out this one. So let's firstly put 1 in the all values of the y in between the y. So I'm going to put this one y 1 1 1, and so firstly it's know that since we know that y naught is this one, y1, y2, and y3, and our value y minus 1, y minus 2, and y minus 3. So since we get y minus 3 here, so we will use n plus 3 c1, n plus 3 c2, n plus 3 c3, and n plus 3 c4, n plus 3 c5, and n plus 3 c6 here. Same as it is, we have just to go down here. So firstly we get n plus 3, n plus 2 c1, and down n plus 2 c, n plus 1 c1, and c1, n minus 1 c1, minus 1 c2, then here n plus 2 c2, n plus 1 c2, and c2, n minus 1 c2, and n minus 2 c2. Here also we will get n minus 2 c2 here, and as it is 3 2 1 0 and 2, and here we will get n plus 2 c3, n plus 1 c3, and c3, n minus 1 c3, and then we will get n plus 2 c4, and plus 1 c4, and you'll get n c4, n plus 2 c5, and minus 1 c5, and here n plus 2 c6. So we have get all this data in the table, and if you don't know the formula, so you can directly go from here for the our given formula. To get our formula, we'll go for the straight line, that is this one, and c1, and the next one is del square y minus 1, that will be this one. Hold a second, and this one, Then from here we will go to n plus 1 C3, that is, and then we will go for this one, and next one will be n plus 2 C5, and then they will go for this one. Since we have got all these value till del 6, now we need to go further. In the Gauss forward, we basically go through this, then again this, again this, and this. Then we go this and go this. So while going through this, we usually use from there to there. Firstly, we will use this one, then we will go there, and we have to multiply this both, then plus, and then NC2 and this one both. Then we have to go to this one and multiply this both. Then on going down from there, we'll go both multiply, and from there this both will be multiplied, and plus with this both will be multiplied. So this will be our given formula. So let's evaluate our given formula here. So we'll get E of 1.17 equals to y net plus NC1 into 0.1619, then NC2 into 0.0079, then plus with n plus 1 C3 with 0.0004, and n plus 1 C4 with 0.000, then n plus 2 C5 with 0.0001, and division with 0. N plus 2 C6 with 0.0001. So we have get the given formula. Now we need to evaluate all this. So firstly, what is the y naught? Y naught for us is, that is 3.1582. That is the y naught, and NC1. So firstly, going forward, first we need to evaluate what is x, what is p and h. So firstly, finding out p and h. So here we are going to find, firstly, for h, we see that h equals to 1.00 by 0.05 minus 1.00, that is h equals to 0.05. Then so, and for the value of p, we put x equal to x naught plus p into h implies, so we put the value of x and x naught, that is 1.17 minus 1.15 divided by what is s, h is equals to 0.05 equals to p. So we get the value p, that is 1.17 minus 1.15, that is equals to 0.2, and divided by 0.05, we will get 0.04. That is the p. The value of p is 0.4 here. So basically here NC1 will be 0.4 here, since NC1. So N will be as it is, and C1 the value of 1. So it will be as it is, and so 0.61619 here. And then we have to find out the NC2. So let's calculate in the raw phase NC2. For the NC2, we know that N is equals to 0.4 here, and so for this, and divide by minus 2 factorial. So we are on expanding it, we get 0.4 and 0.4 minus 2. And here it will 2 factorial into 2 factorial, and then it will be expanded as 0.4 minus 1 and 0.4 minus 2 factorial. This both will be cancelled, and we get that 0.4 into, so we have to calculate, that is 0.4 into 0.4 minus 1, and that will be equals to minus 0.24, and divided by 2 minus 0.12. We are getting minus 0.12. So we have get minus 0.12 into 0.0079 here. Next is n plus 1 C3. So let's calculate n plus 1 C3. That is plus 1 C3. For this, it will 4 plus 1 and factorial 0.4 plus 1 minus 3. That will be equals to 0.4 plus 1, and here it is 0.4 minus 2 factorial again. So we will expand it to 0.4 minus 1 with 0.4 and 0.4 minus 1, then 0.4 minus 2 factorial, that both will be cancelled. Since here it is 3 factorial and 3 factorial, that is 6. So now calculating it, we will get 0.4 plus 1 and into 0.4, then 0.4 minus 1. The value will be equals to minus 3.0.336, and on dividing by 6 we are going to get minus 0.056. So we're getting here minus 0.056 C3 into 0.0004. Now we need to calculate n plus 1 C4. So let's calculate this. That is 0.4 plus 1 and divide by 0.4 plus 1 minus 4 factorial in factorial, that will be equals to 0.4 plus 1, and here it is on evaluating it, we'll get minus 3 factorial. So here we need to expand, that is 0.4 and 0.4 minus 1, 0.4 minus 2, 0.4 minus 3 factorial, and 4 factorial as it is, that both will be cancelled. I need to calculate, that is 0.4 plus 1 and 0.4, then 0.4 minus 1, then 0.4 minus 2, and the value will be equals to this one. And since we know that 4 factorial is equals to 24, and divided by 24, we are going to get minus 0, sorry, plus 0.0224. So evaluating it, the given value, that will be plus 0.0224 into, oh sorry, we don't need to calculate, that will be 0 equals to 0, n plus 2 C5. We will calculate this, that is n plus 2 into C5. So let's calculate it. That will be 0.4 plus 2 factorial divided by 0.4 plus 2 minus 5, that will be 3 factorial into 5 factorial. So on calculating this, 0.4 plus 2, leave it for now. So after evaluating all this value, we are going to get 3.221990209, that is approximately 3.222, that will be our approximate answer for this given value. So this is all about the Gauss forward formula, in which we have shown that how did we calculate this, and this is all about the Gauss forward formula. Thank you. Let's meet in the next video.